Welcome everyone. In this video lecture, we will solve a GATE 2013 question in which we have to find the maximum safe voltage and corresponding charge across the equivalent capacitance. So in this question, it is clearly mentioned there are three capacitors, okay, C1, C2 and C3, whose value are 10 microfarad, 5 microfarad and 2 microfarad, okay, and have a breakdown voltage that the capacitor can withstand, like how much maximum voltage that can withstand. So that are given 10 volt, 5 volt, 2 volt respectively for the interconnection shown below. So this one is the interconnection. So we have to find the maximum safe voltage across the equivalent, okay, and the how much maximum charge that can stored in the effective capacitor. So we have to find the maximum safe voltage in volt and the corresponding charge. So these are the options. So here once again the given thing is is C1 10 microfarad, C2 is given 5 microfarad and C3 is given 2 microfarad and the corresponding breakdown voltage. So I am writing VB1 for the capacitor C1 is also 10 volt, VB2 5 volt, and we can write VB3 2 volt. So we have to find the maximum safe voltage. Okay, so we have to find V safe, or we can write it Vs. Okay, and the Q effective. Q effective. Okay, so these two things we have to find. So our first aim is to find the equivalent capacitance. So the equivalent capacitance we can easily write equivalent capacitance. Okay, so the equivalent capacitance we can write EC. Okay, equivalent capacitance, or better to write C equivalent. Okay, so C equivalent has C1, C2 and C3. Three capacitors here. C2, C3 is in series. So C2, C3 is series. So it means we have to write C2 parallel with C3, and these two series capacitor is connected with parallel with C1. So we have to add C1 just opposite to resistance. Okay, so what we can write, C2 into C3 divided by C2 plus C3 plus C1. Okay, so one can easily solve. C2 value is given, C2 value 5 and C3 2. So we can write 5 into 2 divided by 5 plus 2 plus C1 is 10. So one can write 10 by 7 plus 10. Okay, so it should be 7. Okay, 70, 80 by 7. Okay, so directly I am writing 80 by 7. Okay, and this value will be microfarad. Okay, so this one is the equivalent capacitance. Now we have to find the effective safe voltage. Okay, so for this purpose what I am doing, we are putting a battery. We are putting a battery here, and we are saying this one is a VS, V safe. Okay, V safe. or simply Vs. Okay, so if we will put a battery, so there may be some voltage. So for this one, this voltage will be Vs. Okay, plus minus Vs. This capacitor C1 have voltage Vs that we have to find. And for the time being, we are saying this voltage is a V2 and this voltage is a V3. Okay, capacitor voltage C2 is maximum V2 and V3. Okay, so we can write the Vs value will be V2 plus V3. Okay, we have to find V2, and if we will find V2 and V3, we can say what is the maximum safe voltage. Okay, so in this case, what next we have to do? Here the current in this one, say I is the current. So in this one, we are saying this one current is I1 and this current is I2. Okay, so and the impedance across this capacitor is, we can say, 1 by SC2, and the capacitance for capacitance C3, the impedance, or I am writing ZC2, we can write it 1 by SC2, and ZC3 impedance 1 by SC3. Okay, and in both the capacitance, in the both the capacitance, there will be same current I1. Okay, so the I1 value will be V2 divided by 1 by SC2, or we can write as SC2 V2. Okay, and similarly the I1 value for this C3 is also, we can write V3 by 1 by SC3. We can write as S, okay, write SC3 V3. Okay, because in this case this voltage will be V2 and this will voltage across this one will be V3. So we can write it SC3 V3. Now both the current will be same because this one is the capacitor C2 and C3. Okay, and the corresponding impedance 1 by SC2, 1 by SC3, and the corresponding voltage is V2, corresponding voltage across V3. So current, this current I, the same current will flow from this one. So this I will be V2 by 1 by SC2 equals to V3 divided by 1 by SC3. So this one is nothing but simply we can write SC2 V2 equals to what? SC3 V3, nothing but simply I. The same thing we are writing here. Okay, here I am writing as I1, so write it I1, I1, I1. Okay, so both are same. These two current will be same. So we can write this I1 is same in both the cases. So the same line I am going to write SC2 V2 SC3 V3. Okay, so this S cancel out. So we can write C2 V2 equals to C3 V3. So this one is very important relation that we have calculated. Now we have to think about the maximum, how much maximum voltage in the question, how much maximum voltage C3 can withstand and C2. So VB1 sorry, no need to VB1. VB2 is 5 volt and VB3 is 2 volt. Okay, so these two things are given. So for example, now if we considered, let VB2 is 5 volt, that is maximum voltage V2 can extend, okay, 5 volt. So we can write as C2 into 5 into C3 into V3. So V3 value will be C2 by C3 into 5. Now what is the value of C2? C2 is 5 microfarad, 5 microfarad, and C3 is 2 microfarad. So C2 value, so 5 into 5 divided by C3. C3 is 2. So this should be 25 by 2. 25 by 2. So 12.5 volt. So V3 value is much greater than VB3. So it cannot be possible because VB3 is given only 2 volt. So this V3 can maximum reach to 2 volt. Okay, is it clear? Once again, I am repeating this point. If we are saying that maximum voltage V2 is 5 volt is equal to the breakdown of the capacitor C2. So if we put that value VB2 5 volt, okay, so it will give V3 12.5 volt, but V3 maximum we can get 2 volt. So this will be the means not a voltage that can withstand by the capacitor. So we have to remove this portion. So now other case, let let VB3 is 2 volt, okay, and we are saying this one is the maximum voltage that can withstand by the capacitor C3. So again we have to use the same relationship, C2 V2 equals to C3 V3. Okay, so here VV3 is given. Okay, so C2 V2 C3 into 2 volt. Okay, so here from V2 we can easily find C3 by C2 into 2. So C3 value is given 2 microfarad. Okay, 2, and this should be 5. Okay, C2 is 5. Okay, and 2. So this should be 4 by 5. So 4 by 5. If we divide 4 by 5, so it should be 0.8 volt. Okay, 0.8 volt. So we can observe that if V3 is maximum voltage, because this one is 2 volt, okay, C2 will carry only 0.8 volt. So it is the acceptable range because this V2 value will be 5 volt. So it can be acceptable. So 0.8 volt and V3, the maximum voltage across the V3 will be 2 volt. So we can say that this V3 maximum voltage for the C3 will be 2 volt, okay, and for V2 it will hold 0.8 volt for this combination. So the safe voltage, this Vs, will be our 0.8 plus 2, that you have 2.8 volt. It's a very simple thing, but we have to go step by step. Like if we put 5 volt, then our V3 will be 12.5 volt. So it can't be acceptable because V3 maximum goes to 2 volt. So it is not acceptable. In other case, if we write V3 2 volt, then V2 0.58 volt, but it can go up to 5 volt. So it is acceptable. So the safe voltage we have already calculated. The safe voltage is nothing but simply we have to add this one. This Vs equals to Vc2 plus V3, Vc3. Okay, safe voltage. Here I am highlighting this one. Safe voltage. Okay, so the safe voltage will be this one. Now the other part we have to find the Q. Q effective. So Q equals to C equivalent into V effective or V safe we can write. Okay. So the C equivalent we have already calculated the equivalent capacitance T by 7 microfarad at T by 7 microfarad into V safe 2.8. Okay. 2.8. So just solve it. So it should be 32. So the correct answer will be 2.8, 2.8 and 32 because we have to find the corresponding charge in microcoulomb. So microcoulomb. So that's why this one is microfarad. So this one is microcoulomb. Okay, because this one value is microfarad and in this one is in volt. So it should be in microcoulomb. Okay, so the correct answer for this question will be 2.8 and 32 microcoulomb, 2.8 volt. Okay, so this is all about this simple question, but we have to know some basics where we have to use Kirchhoff's voltage law. So this Vs will be also same 2.8 volt, and we have just find this one voltage V2 and V3 for the calculation of safe voltage. Okay, so this is all about this question. So thank you for watching this video.